Hello everyone, I am Nishchita SN, 3rd SEM BE, Department of Electronics and Communication, currently pursuing in Sri Venkateswara College of Engineering, Bangalore. In this video, I am going to discuss about the subject mathematics. In that, the topic is about Fourier transformation. First, introduction to addressing mode. Addressing mode is a concept in computer architecture that determines how an instruction refers to the data it operates on. It specifies the way in which the operands or data are accessed and presented to the CPU. The addressing mode is an important factor in determining the efficiency functionality of a computer system. Addressing mode refers to the way in which the CPU accesses data or operands in memory. It determines how the CPU calculates the effective address of the data. There are 6 types of addressing modes. First one is immediate addressing mode, direct addressing mode, indirect addressing mode, index addressing mode, relative addressing mode. First, we know about the immediate addressing mode. In immediate addressing mode, the operand is directly specified in the instruction. The value is usually a constant or a literal. It is useful for operations that do not require memory access, such as arithmetic or logic operation. In immediate addressing mode, the operand is included in a instruction itself. It is useful for storing constants or immediate values. In this mode, data is presented in the instruction itself and the processor loads the data directly from the instruction into a register. Example is add R1 hash 5. In this instruction, the immediate value is 5 is added to the contents of register R1. Next example is R1 hash 10 loads the value 10 into the register R1. Next one is direct addressing mode. Direct addressing mode uses a memory address to access the operand. The memory address is specified directly in the instruction. It is commonly used for accessing global variables or constants. In direct addressing mode, the operand is the address of the memory location where data is stored. In direct addressing mode, the operand is specified by a memory address. The memory address is directly included in the instruction. In this mode, the operand address is directly specified in the instruction and the processor retrieves the data from the memory location specified in the instruction. Example is move R2 R1000. The instruction moves the constant contents of memory address 1000 into register R2. Second example is move A 2000H loads the value at memory address 2000H into a register A. Next one is indirect addressing mode. Indirect addressing mode uses a memory address stored in a register to access the operand. The instruction contains the register that holds the memory address. It is useful when the memory address is dynamically calculated or when accessing arrays or data structures. In this mode, the operand address is not present in the instruction itself. Instead, the instruction contains a pointer to a memory location to contains the address of the operand. In indirect addressing mode, the operand is a memory address that contains the actual address of the data. In indirect addressing mode, the operand is specified indirectly through a memory address stored in a register. It allows for flexibility in accessing memory location. Example is LDR R3 or RF. The instruction loads the contents of the memory address stored in the register R4 into register R3. Move A at RO loads the value at the memory address, so the RO register into the register A. Index addressing mode. In index addressing mode, the operand is obtained by adding an offset or index value to a base address. It allows for efficient array or table access. The operand's memory address is calculated by adding an offset to a base register, useful for accessing arrays or data structures. In this mode, the instruction contains an index register that is added to the base address specified in the instruction to obtain the address of the operand in the memory. Example, load R1, R2 plus 10, load the values from the memory address obtained by adding 10 to the value in register R2. Next example is move A R2 plus 5 moves the value at the memory address stored in register R2 plus an offset into a register RA. Next is relative addressing mode. In the relative addressing mode, the operand is specified as a displacement relative to the current program counter. It is commonly used for branching or conditional jumps. The operand's memory address is calculated by adding an offset to the program counter. Enables conditional or unconditional branching. Example is jam 10 jumps to the instruction located 10 bytes ahead from the current program counter. Summary: addressing modes determine how the CPU accesses data or instruction in memory. Different addressing modes various way to specify operands for an instruction. Each addressing mode has its advantages and is suitable for specific programming scenario. Conclusion about the addressing mode is understanding addressing modes is crucial for efficient programming and optimizing memory usage. Different addressing modes have different benefits and trade-offs. Choosing the appropriate addressing mode can greatly impact the performance of a program. Thank you for watching this video.